Okay, so keep in mind that our exam is over 2 days, beginning tomorrow, or excuse me, beginning Wednesday. We will take your third portion of your vocab quiz tomorrow, and then we'll get that handed back to you because you have the first two that were returned to you. Part one is your general question, your vocab, and maybe something like which of the following is associated with activating pepsinogen to form pepsin, or how many different types of saliva glands are there, and the primary function of teeth is to do what? Questions like that you'll see on Wednesday. Then Thursday will be what I think is the most important portion of any exam, whether it's in the physical sciences. To me, problem solving is always going to be more important than not that vocabulary isn't, but you're using that to solve problems. And then when it comes to the life sciences, able to describe some of these processes is probably more important, at least to me it is, because when we have multiple choice questions and vocabulary questions, you can still guess. Will you right? Maybe, maybe not. But you still have to be able to write these complete sentences for the second part with the diagram and the essay format. So, with what part do you think you need to? Is it one? Should we go over, for instance, what I think you would probably see? Okay. So, even though this is a secondary organ in digestion, it's probably the second most important organ, probably behind the brain. And what might that be? Just guess.
Okay, it's either the liver or the pancreas. That's one of them, right?
Yep.
Okay. So the pancreas though is more like hormones.
Yep.
But the liver, and like you can like if you lose the liver, like I think the pancreas is more important.
Okay.
It's liver, isn't it?
I think it's always going to be a question of debate. I mean, it doesn't mean that you're wrong, but in our estimation and what we think, or and maybe I'm overstating my opinion, but I think it's the liver that's more important because the reason I say that is, can you take artificial hormones for sugar metabolism?
Oh, absolutely.
Yes. So, when it comes to, to finish that, should you not be able to break down um, sugars appropriately? Well, that is secreted by the pancreas, that's true. But that hormone has an effect on which gland? Of course, that's the liver. So, with that, you can take those artificial hormones and inject yourself with them, but you can't live without your liver because of the functions that it does. So,
So you can't have your liver leak?
well, I think you can, just not all of it.
It just filters everything and it's just like
Well, it's not that it does. Filter's kind of a vague term. Your kidneys maybe do most of the filtering. It's what the liver does as far as converting things that they can be filtered then. It kind of works hand in hand.
really underestimated the liver.
And we're going to discuss why that is, that it's not so much a filtering process. It changes things so that they can be filtered. Okay, so
Like what even is a colon? Like does it just store bile? What is what all does the bladder do?
that's really all it does.
Okay, so
Yeah.
like do we really need it?
No, because one of the things we said in class is it's not the only show in town for breaking down fats. Because,
It just makes the process more efficient.
well, it does, because one of the things when we look at dietary proteins, the most efficient enzyme to do that would be pepsin. But pepsin's not the only enzyme or only show in town. You also have pancreatic amylase, and you have amylase, and there's probably other enzymes that we don't discuss at this level. The next one you probably will. But then when it comes to that of breaking down fats, bile is just the most common one, kind of like pepsin is. But again, it's not the only show in town. What else can break down fats? It's one of the things we said in class. It comes from a different gland. P. We've talked about it already today. That's the enzyme, not the gland.
Okay.
The pancreas.
Right.
Because there's two enzymes that the pancreas will secrete. So it's not as efficient as bile, but it can still get the job done. You probably have to really watch your diet as far as how much fats you're taking, saturated fats and whatnot. Yeah, you can break them down, probably just not as efficiently. So once you start cutting that back, then you're allowing that compensation for your pancreas to kind of take the place of what the gallbladder normally did. So in discussing the liver, what are the major functions with, okay, so one of the things we would say these three things, okay? Dealing with proteins, that's probably the most important function of the liver, okay? Then also dealing with different types of metabolism. Now, the liver can't do that unless it gets the signal to say, hey, you need to start doing this from the pancreas. Okay, so major functions with protein and carbohydrate metabolism. Finally, what are some secondary functions? Okay, so to me, I think the best way to approach this is look at, okay, so what are these major functions that deal with proteins and carbohydrates? So this is big, okay? This is probably the one of the bigger essays that you're going to see because there's only two, okay? And in a chapter this big, you probably could throw out multiple ones, but our philosophy is let's hit the big targets here. Okay, so when we're dealing with protein and carbohydrate metabolism, let's start with proteins, okay? So what is it doing? Well, it's not only just synthesizing proteins, but one of the things we did talk about in class when it came to the birds, okay, as that embryo is developing, there are certain toxins that are going to start to build up, okay? But your liver will compensate for that. That's another function that we talk about in this protein metabolism. And then there's one more that actually goes in the blood. Now, that doesn't mean anything to you right now, but there's many proteins found in the blood, whether it's for metabolic purposes, but mainly clotting purposes. Okay, so as we begin with this protein metabolism, okay, so remember, you're going to have to connect the dots, all right? So I think we just said it synthesizes proteins. I just want to double check here because I don't want to be writing something down and then say, oh, no, that's not right. So let me check just to be sure. Okay. Okay. The liver will perform, we'll say that, will perform or function in protein metabolism. Okay? So what that means is each individual, all three of us is going to be different. Okay? And anabolism is how you build materials up. Catabolism is how you break those materials back down again. Then your metabolism is the middle of the road. It's a balance between the building up and the breaking down of substances. So with this liver, this is probably one of the most important aspects. It's functioning of those building and breaking down of materials. Anabolism. You don't need to know that for this part. We're not going to be that specific. Okay. All right. So, another one, okay. What would it be like if when we were developing in the mother's womb, if we were not hooked together by an umbilical cord? Because we can get rid of those wastes. As you're developing, your mom takes care of that for you. But in other animals, like we said with birds, toxins will build up. And they do inside of us as well, okay? And that substance is what we call urea, okay? And when we extend that word out, what do we picture when we hear the word urea? Urine. So we don't just urinate because it's just something that we feel we need or want to do throughout the day. We do that because your liver is converting and breaking a lot of these substances down so the kidney can remove some of them substances. Okay, so well, it's not so much that your body can't use it, you're just reabsorbing it for the water purposes. That would be my interpretation. And I think you really got to have the right type of substances. And my guess would be you'd almost have to boil it too. I'm not a survival expert, but Bear Grylls is. I kind of like watching that. And I don't know what all you'd want to do to possibly try to drink your own urine.
Well, if that was all you had, you didn't have any water, you're urinating some water out. If you just keep drinking that, your body's going to start to absorb all that water. So eventually, what you're drinking, you'll have to drink water. So you could do it to an extent for a certain amount of time.
But it's not a fix-all substance. You need that water. Yep. Okay, so in this case then, okay, the liver will break down urea to uric acid. You'll notice I keep talking while I'm writing in case it doesn't make any sense or you can't read it. Okay, so the liver will break down urea to uric acid so the kidneys can filter that. Not substance. Okay. Oh, I suppose, but you'd be fine just with just one. Yep. And okay, so then finally, these are major functions of the liver. We'll say makes or synthesizes clotting factors. Okay, now At this level, you don't need to write it down, but if you were responsible for them, I would venture to think that the only clotting factor you should be thinking about is just platelets at this level. Next time you see this, probably down the road, you're going to be talking about something like thrombin, fibrinogen, fibrin. Those are all different types of protein clotting factors that actually take place, because there's a little more involved. When we think of a scab, that's all platelets that do that. Well, that starts the reaction, but what happens is you have these other proteins that kind of create a mesh around that wound, and then once they start doing that, they start to tighten. And then when they start to tighten, that really helps clot that site. And then that's where your fibrin, thrombin, and fibrinogen all come into an effect for these clotting factors. But that's just what we want to know them for, is just what clotting factors, where they come from, which is proteins from the liver. Okay? So, what do you think? Oh, what about carbohydrate metabolism? I'll let you think about it. It has to get the signal from the pancreas first. So I'll do something like this. This will maybe jog your memory. Well, it's not so much that I suppose you could say it makes it less harmless, but those rings or structures are just what type of molecule? It starts with a G. Think we're talking about sugar now.
Glucose.
Yes.
And then
Glucose.
it turns it into something else.
Right. Okay, so which one would you guess is a high blood sugar level? The one on the left or the one on the right? The one on the left, because you have all those glucose molecules floating around in the blood. Okay? So, from that, we will expand this out and say, when, we're going to say BSL, you can write blood sugar levels out, but when are elevated, okay, so you have all this glucose floating around in the blood. You need to lower that level. So, what's the pancreas going to do? It's a hormone to the liver. It's insulin. That's right. Okay. The pancreas sends insulin to the liver. So it's going to do one of two things. Okay? It's either going to cause this hormone insulin, either going to cause this glucose to be burned up in your cells, or what more commonly, what do you suppose is happening to these glucose molecules when they get converted to this known as glycogen? Okay? Right, and what happens is when you store all these glucose molecules and change those monomers to polymers, you're changing the substance, therefore you're lowering your blood sugar levels. Because you don't have glucose anymore, it's glycogen, like you just alluded to correctly, which can be what? Well, what you said earlier. It starts with an S.
Stored.
It can be stored. That's right. Okay?
It's the insulin that does this, right? Insulin isn't just like insulin just sends the liver as like a messenger that's like hey,
Right. The insulin has nothing to do other than saying, liver, we need to do this.
it's just a messenger.
It's just a messenger. It doesn't do the function itself. It's a hormone. That's right. Okay. Told you this was, hopefully we said this is going to be a big one. Now, one of the things I want you to keep in mind is this seems like a lot. I would agree. But if we wanted to lower the standards, we certainly could. But I don't want to lower the expectation of ourselves. We want to raise the bar, not lower it. Okay. So if there's a way to lower the blood sugar levels, there's a way to tilt it back the other way to raise it then as well. So if you're going from glucose to glycogen to lower the blood sugar levels, what's going to happen when you change the glycogen back to glucose? It's going to raise the blood sugar levels. That's right. It is another hormone. Right. We do. Starts with a G. It's not glycogen. It's gluca something. It's glucagon. I think we had talked about that. This is a lot of information in a short amount of time. Don't feel frustrated. Oh my gosh, I don't know this. No. So then, when blood sugar levels are low instead of high, okay, are elevated or high, just the opposite is going to take place, okay? The pancreas will send glucagon to the liver, okay? So once that glucagon gets to the liver, what's going to happen?
The liver is going to be like, oh, buddy, it's a little low. Let's break up these glucose.
This glycogen.
And make it into glucose.
That's right. Okay? Sending glucagon to the liver to convert, that's what I thought we said, convert glycogen to glucose. So now, rather than having this big, long chain here, this glucagon then sends a message to the liver. Let's start breaking them into these individual molecules then, and that raises the blood sugar levels.
It's like anytime you eat something, like your blood sugar changes.
It's not going to be immediate, but it's going to change. And should a person want to try to lose weight, okay, by exercising, maybe have something light, like for myself, before cross-country practice, I'll just have some grapes, because I don't want anything like cereal or eggs or something like that, or else when I was younger, I'd probably just throw it up, because I just wouldn't set very well. But now when you have something light like these grapes, then do your workout, then you have the opportunity to call on. You two don't have any. When you get to be my age, that's true. Okay? So enjoy that while you can, because like I said, you don't have any reserves. But it's nice to have them. So when you don't take anything in, you can start to burn some of that fat because you need that energy. Otherwise, if you consume something a little heavier and you don't throw it up, you're just burning what you just took in.
And I heard it's really good to run like on a fast, you burn like a lot. Because you're literally just like, you're burning pure fat.
Right. Okay, so that closes we'll come back to that. Well, that closes the door on the major functions. We're running out of time, so the next essay just deals with we're going to finish this tomorrow. The next essay just deals with protein enzyme metabolism and how that takes place. Where you need to talk about the stomach, the small intestine, and everything involved in between there to break down proteins. All right, so with that, we will catch up to you next time.